So today we heard about streaming data with Pulsar on Astra Streaming, real-time data in Cassandra on Astra DB. We actually heard a bit about change data capture as well, which was interesting. We heard about vectors. I'll just explain a bit more about that, the indexes around that. And we also heard a bit about embedding models. Media Distillery talked a bit about that as well. And also these embedding models, they're easily usable within our platform as a service. Normally you would have to program some stuff together and then reach out and set them up and use a REST endpoint at some kind of AI provider, or use Hugging Face, or use it on local machine. But we've got you covered with that as well. And then we think it's really important to be able to run it everywhere. Right. Also today we saw that not all of the data is in the cloud, but a lot of data is on premises. So that means that all of this should easily run on premises as well. And that's actually possible because of container platforms. We think it should also be able to run on cloud providers, right, as a managed service, because really, who wants to go through the pain and hassle of managing all this stuff themselves, right? Some have to, but I think if you have a choice, you probably don't want to. Security is super important. We spoke about the EU AI Act. We spoke about governance. We spoke about the fact that you have to have security in place and auditing about the security as well. So that's where state-of-the-art security comes in. And then, of course, developers, they have to use all that functionality. And that's where a data API comes in. And, instead of thinking and implementing the 20th data API, we decided to just use the best data API out there, which is probably the Mongoose data API. So everybody who has been working already a bit with MongoDB can easily work with this platform as well. And that's what we call developer efficiency. Rapidly prototyping and then putting some stuff into production. I'll show you how that's done with the Langflow application. And all of that together, well, this is a name that we kind of made up ourselves, but I think you could call it a smart context in AI foundation. That really helps you to put data together and to make use of all of the AI tools out there. And once we get there, right, it's not something that has to be a big bang approach. We've seen organizations speak about using components out of the stack, right? It's not like you have to build everything at once, but components out of the stack, it means that you can start connecting your disparate data sources, your silos, to a platform that can be trusted. And from there, you can start building all these amazing, cool applications, websites, but also, I like to stress that, transactional applications, right? Because typically traditional AI has been a bit in the domain of batch analytics and things like that. And then the resulting models, they have been used, of course, in transactional environments. But now you have access to all of your data for transactional applications. Okay, enough talking. Demo. The first thing I'm going to show you is vector search with Astra DB. What I'm going to do is I'm going to ingest a PDF document, use the vectorize capability of the platform to store the PDF document into the database, including the embeddings, and then using an approximate nearest neighbor search, I can actually run semantic searches on that content. And that's really cool, right? Because now I'm not only searching for metadata or for full text, but I can ask semantic questions to my database, and my database will understand what I mean, just like my neural network in my head does as well. Okay, let's start with the easiest chatbot possible, right? So I just have my chat input over here, my chat output, and I just created a parrot. So when I say hello, it says hello back. When I say hi, it just says hi back, right? Great. Now, I want to make it a bit smarter. And to make it a bit smarter, I can just introduce a large language model. Right? So here's an OpenAI model. I'm going to connect the chat input to the input of the model. And then the output, I'm going to connect that to the chat output. As you can see, I can configure some stuff here. I'm using GPT-4o Mini. That's all fine. The OpenAI key, I pre-configured that. But this is essentially a bit of a smarter model. And now when I say hello, the large language model will come back with something more meaningful. And it will say, hey, how can I assist you? Right? But we're still not really there. Because what I would like to do is, I've got a white paper here. Hey, it's a DataStax white paper about the future of enterprise architecture with agents. So that's a really interesting document, and I would like to be able to ask questions around that and use semantic search. To be able to do that, I'm going to use my database. So as you can see, this is the UI for Astra DB. I've got a few databases over here. I'm going to use my vector database. And in my data explorer, I can create a collection. Let's call that Heartbeat. And within that collection, I tell the collection to use OpenAI as an embedding provider. And within OpenAI, I want to use the text embedding tree small model. So once I've done this, I'm actually creating this collection, and all of the data that goes into the collection will also go through the embedding model. Well, I can tune that because sometimes you don't want all of the data to go through the embedding model and maybe just some fields of the JSON data. But essentially, it makes life really easy. So my collection is created. I've got 0 records. Now, let's take my flow and extend it a bit. So I want to ingest a file. And this file is going to be the Systems of Automation PDF. Finally, what I want to do is I want to load that file into my Astra database, into the collection that I just created. So that's in the vector database. My collection is Heartbeat. And I want to use the Astra vectorize functionality. Like I said, right, we don't have to do all the embedding stuff ourselves. We can just use whatever available in Astra DB. And as you can see, it's quite a lot. So in this case, it's OpenAI. I'm going to use the text embedding tree small one. And I just need to provide my API key, and that's it. Now, I've got my file. This file has a lot of pages. So if I just dump this file into my database and create one vector embedding out of it, it means that my vector embedding, the granularity of the information, is very small compared to the data that's in the PDF. So typically what we want to do is we want to chunk it. Chunking is a mechanism in which we take smaller parts of the document so that the granularity of the resulting vector, the semantic knowledge, is much larger. So to do that, we're going to use the recursive character splitter, which is a LangChain component. LangChain is fully integrated here in the application. So the PDF file goes into the character splitter. The character splitter then returns those chunks into Astra DB. And now I can load this, run this process. You can see that these boxes, they are being used one after the other. The file loader took 1.2 seconds, the recursive character splitter took 106 milliseconds, and then 1.7 seconds for Astra DB. Great. When I go back to my Astra database and I reload the page, we can see that I actually have 20 records in my system now. And we can also see that there is a vector search capability here. So what I could do now is ask something like, what are agents good for? And that's a query that normally wouldn't result in anything. right? Because if we run that as a full text search, well, it won't give me back anything. If we run it as a metadata search, it won't give me back anything. But now it will actually give me back those chunks of information that are semantically most close to the question that I ask. So let's run that query. And then we can see that we've got some similarity scores here. It's descending. And then if we take a look at the content here, it says something like they can fully grasp novel concepts to react to new situations. AI agents that use capabilities to ensample context can also use capabilities to complete tasks. So I think this is a pretty good match, right? Out of those 20 pieces of information, we actually got the right information. So now let's go back to my super simple flow over here, and let's try to use that information in our flow, right? So I'm going to keep the large language model, going to introduce Astra DB over here as a vector search database. So my chat input, which is my question, goes into the search input. Choose my database, which is the vector database, and the heartbeat collection. Of course, I have to choose the embedding model, because the embedding model is going to be used for the chat input. So it was OpenAI with text embedding tree small, and then my OpenAI key over here, and we're done. So now when I run this query, and actually we could run that because I could ask here what are agents good for. If I just run this, we will see that it takes me 1 second in total in this case. But I can have a look at the search results over here. And this is super handy, right? Because now immediately I can see, oh, what did the vector database actually come back with? It's the same exact document that we're just looking at. So this is really good. Now the next step in retrieval augmented generation is passing this information on to the large language model, including the question that I asked, and then it can come back with a nice answer. So let's just create that. The only thing that I need to do for that is I need to parse my data, because I'm only interested in the text piece of it. And let's put this a bit to the side. And I need to create a prompt. I think prompt engineering is a very interesting topic on itself. And let's just create a prompt 101, right? So this is the hello world of prompts. Something like, given the context, and then here I want the context. This is the context that comes from the database. Answer the question, and this is where I'm going to put my question. Okay, that's it. Now you can see that I have 2 new inputs here in my prompt. So the output of the vector database goes into the context. And remember the chat input, this is the question, that goes into the question. And now I have a prompt that means something for a large language model. And this is essentially our complete flow for a chatbot. And now I can run it. So if I ask my question again, what are agents good for? Now the question goes to the database. We're running a semantic search. We're getting back the chunks. Those chunks are then passed to the prompt. The prompt is passed to the large language model, and we have an answer. It can be as simple as that. There is a question.
Wondering, because this is so easy, and I can really see it being useful, especially for like part of development. Can you access the backend Python code as well? Like, so you can like make a part of your flow and then just get back to the Python and then integrate it into your front end, etc.?
Yeah, so it's like we rehearsed this question, which wasn't the case, by the way. But really good question. I will just skip the result, right? I mean, we can also all see that the result that the LLM gave is pretty good. Actually, so this is the playground part. The part that you're asking for, Fausto, is the API part. So to integrate this whole flow into a front end, I can just call this REST endpoint and I'm done. So I can do my whole development with low code. You could do it with no code as well, because I didn't code anything. But you can also do it in a low code way, because you can create your own components, which is really interesting. And then just call out to the REST endpoint and you're done. If you want to integrate it through Python, then you can do that as well. Or if you, if you want to use the JavaScript API, that's possible as well. 5 minutes. Okay. So this is that answer to your question, Fausto? Yeah?
Well, the second was, is there also observability out of the box? But I mean, that is solved if you can just...
So observability, that's a really cool topic as well. And also we didn't rehearse that. I think there are some people here that do a lot of observability. So there is an integration with external tools like, for instance, Langflow. And that's the beauty of Langflow, right? Langflow is a DataStax product, absolutely. It's fully open source. I mean, DataStax is the open source company. I think that's pretty clear by now. And Langflow is open source as well. And the open part also extends to using a lot of AI tools out there. So even if you want to use another vector database apart from Astra DB or Cassandra, you can do that, right? It's an open platform. But Langflow is one of the capabilities to do observability.
So the question, what is observability out of the box? What is it?
So observability means that you can track what's actually happening in the flow. So interacting with large language models, especially when you start interacting with agents, for instance, they have a life of their own. And it's very important to understand what's happening. And with an observability platform, you can also assess the quality of the results, for instance. So I built this application. It's a very simple Streamlit application. I'm not a front-end developer, but even I can build some front-ends, simple front-ends, with Streamlit, but it works. And I called it What's Up in the World. And the idea came about when Wikipedia said that they wanted to use Astra DB as their vector database. And I was like, yeah, but this is really interesting. In fact, if everybody on the whole world is editing Wikipedia articles in real time, then if we can subscribe to a real-time stream of those articles being rewritten or edited, we can get a pretty good sense of what's actually happening in the world without a source of news. Because all of us can go into Wikipedia and write about Syria, about technology, about whatever, about the elections in the US, right? And people do that. And that means that if we can capture that stream of information, I think it's really a stream of unnuanced information. Of course, maybe there is some stuff that doesn't make sense, but hey, it's a really interesting concept, I think. So that's what this application is about. What we're going to do is we're going to use Astra Streaming or Apache Pulsar as a streaming platform to make sure that we have guaranteed delivery of those updates. So we're taking those updates in real time from Wikipedia. Yes, you can do that. There's an API to do that. So, if you want to have a look into that, that's really cool. I wrote a little simple Python script that's called a producer. It's connecting to the API of Wikipedia, and it's dropping all of that information onto a topic in Pulsar. And I love that. That's why I call it data is the new API. Because the fact is, the only thing I need to do is just call producer.send, and as a producer, I'm done. I don't have to worry about anything anymore because Pulsar is the underlying platform that will make sure that there is guaranteed delivery to whoever wants to listen. And that's so cool, right? If I think about microservices architectures where I have to implement, hundreds of lines of retry algorithms and things like that because maybe the receiving end is not available, that's where I get nightmares from. But now you can see here, this producer that's in and I'm done. That's how cool Pulsar is, right? Once it's on a topic, I'm taking it from a topic and I am actually enriching it, right? So this is called stream processing. And stream processing is super cool as well. Because with stream processing, I can take the message and then I can enrich it, or I can change it, and I can alter it. I can do with it whatever I want. And then I put it on a new topic. And then I can start listening from that topic. So that's what we're going to do. The stream processing function here in this part actually takes the original message from Wikipedia and then adds a so-called vectorized field in the JSON data. And the vectorized field, that's the thing that's being used by Astra DB to create those vector embeddings. That's as easy as it is. So let's have a look. I've got my IDE over here. By the way, this is for the techies over here. I love working with Cursor. Cursor is really amazing. So if you haven't done so, then please have a look. And what I can do is I can start my producer. So the producer just started. When I move to my streaming environment, also in the UI, there is a try me functionality over here. And I can subscribe to the consumer topic, which is the wiki stream. If I connect to that, you will see that all of those messages that are being generated on Wikipedia in real time by all those thousands of people out there in the world, we're actually reading them here in Pulsar streaming. I can also read the enriched version, and that's this one. So, as you can see here is this data structure looks a bit different, and we've got the $vectorize field in here that now is going to be used by Astra DB. So in the backend, just real quickly going back to this one, you can see that there is a function here that's a Astra DB sync. And the Astra DB sync makes sure that the data is stored in Astra DB. Okay, so if we go back to Astra DB, to my other database called Wikipedia, the Data Explorer, in the Wikidata, you can see that indeed we're getting all those messages read into Astra DB. And that means that now already I can start doing some cool stuff with vector search, like for instance, running real-time classifications. Like I said, large language models are really cool, but just vector search is even cooler maybe, because you can use it for so many things, right? So if I would ask a question, give me some news about celebrities, bam, there you have it. That's a classification right there. Normally, I would have had to train a traditional or a discrete, like McKinsey said, AI model for days, weeks, months maybe, tag data, this is celebrity, this isn't. Now with vector search and an embedding from OpenAI or any other embedding provider, I have classification at my fingertips, right? So if we take a look at the data over here, well, it starts with really great information about deaths from famous people. But anyways, there is an award for animation that's done, a thriller film, another list of awards and achievements of somebody. This is classified information, a classifier on information. So now let's switch to the actual application. And this is the application that I just used. In this application, we're using both the Pulsar stream. So let me just quickly show you that. We're using both the Pulsar stream because when I have a topic, I can read from that topic. And the beauty is that I can get my data in real time, right? I can't do a lot more with it because it's not in a database, but I can read and process all of the data that's put on a topic in real time. And then also we're going to connect to the database to do similarity search. So let's have a look at how that looks like. To subscribe to the topic, I just click the toggle button. So there are like 300 documents that have been streamed in. If I run my producer again, because it only reads 100 messages per time, you can see that in real time, I'm actually seeing what's happening on Wikipedia currently. And that's done through Pulsar with guaranteed delivery. All right, so this is pretty cool. Something else that I built in is the, remember the classification functionality? Well, it's built into the app as well. So what we're doing here is give me the last 5 articles of political news. And well, it does that really nicely. And then it also plots some of that data on the map if possible. And this is something that's really interesting as well. Fausto talked about Pydantic. And Pydantic is a technology that is very old already. It allows you to create structured classes in Python. But providing a bit of information, a description into a Pydantic class, it actually allows you to combine that with a large language model. And then the large language model will come back with structured information from unstructured data. And that's where I think, AI and large language models can have a big effect on new business use cases. And this information, these 3 pieces of information, they're coming back from the large language model. So we're passing the data to the LLM, and we're asking it to give us back structured information about the categories and about the sentiment. And again, previously I had to use a sentiment model that was trained on my data, etc., etc. But hey, now the LLM does it all, right? The last 2 pieces of this is an interaction with large language model. So I could ask my large language model and my database to construct a news bulletin about positive information. Well, let's see. And here we go, right? The vector database, Astra DB, is being used to pull up positive information. Again, it's kind of a classification question. And then that information is passed to the large language model together with my original question. So I'm getting a wonderful good news bulletin. Who doesn't want that? And then lastly, to show what Fausto just asked about productionalizing the Langflow flow, I built a flow here that's called What's the World Talking About? And you will probably recognize the flow, right? It's pretty similar. It's a chat input, the database, a prompt, a large language model, and a chat output. So this is my functionality for the large language model and the retrieval augmented generation. If I want to productionalize this, I just need to copy this an API endpoint over here. I'm going to inject it in my application. If I ask something like I don't know, tell me something about celebrities, I don't know. It will probably understand. And indeed, it comes back with some information about celebrities, right? So it's pretty easy to put this stuff into production. And that's actually what I showed in this diagram. So with that, here's a QR code. If you want to try it yourself, just sign up using the QR code. It will give you access to Astra DB. It will give you access to Astra Streaming and also to Langflow. And on top of that, you'll get a $300 credit to be used for a year. And with that, you can actually build quite a lot. So yeah, like I asked this morning or at the beginning of the day, what data will you modernize today? Thank you very much.